Hello, I'm Leighton Marcus,
And I'm Kevin Houghton.
and we're here to talk to you about quadcopters, or also known as drones.
So some of the basic features you're going to see in drones are that there's going to be 4 electronic motors that are going to function at different speeds depending on which direction you wish to go with it. There's 4 electronic speed control modules that are indicating the speed that the motors are working. There's 4 propellers that are going to keep the drone in flight. There's a flight controller that allows you to actually control the drone. There's a mainframe that houses all the wiring and the electronics on the drone, and there's a battery that is of course going to power it.
So you're probably wondering how a user communicates or controls one of these quadcopters or drones. And it uses a radio spectrum of 2.4 and 5.8 gigahertz. This spectrum or radio band is under the category of ISM, or Industrial, Scientific, and Medical Radio Band. And this is what, like I said, the transmission medium is for the transmitter and the quadcopter to communicate. The transmitter uses 2.4 gigahertz to communicate with the quadcopter, and 5.8 gigahertz frequency is used to relay video to and from the quadcopter if that's how the user has it set up. The transmitter is constantly sending this signal back to the quadcopter during flight, and this how the quadcopter receives this signal may be built into the flight controller board or a separate module. A user can also gain a better view when using one of these quadcopters if they use something called FPV, or first person view. The user uses a 5.8 gigahertz camera to communicate video signal back to a viewing source that accepts this 5.8 gigahertz frequency. Like I said, using FPV allows the user to make maneuvers that would otherwise be impossible without the use of the FPV setup. Otherwise, the user is just flying in a line of sight and just looking at the drone from where they're standing at.